Hello friends, American farmers pour their hearts into producing millions of tons of food each year, turning vast fields and livestock into meals that nourish families nationwide. How do they leverage state-of-the-art technology to deliver safe, delicious pork to your plate? This documentary traces the path of pork production, with harvesting at its core, showcasing the cutting-edge tools and dedication behind every bite. What challenges do farmers face to ensure quality pork reaches your table, and how do their efforts strengthen rural communities? In the rolling fields of Minnesota, farmers like Emma Larson rise at dawn to manage high-tech pig barns, preparing for the critical work of harvesting. Harvesting in pork production means raising pigs to an optimal 280 pounds before they're sent to processing plants for cuts, like bacon or ribs. Emma uses IoT sensors integrated with cloud-based apps to monitor pig health and growth in real time, ensuring precise harvesting timing for flavorful meat. Climate-controlled barns equipped with automated ventilation and feeding systems synced to AI algorithms keep pigs comfortable and healthy. This work fuels rural economies, creating thousands of jobs in towns like Worthington, Minnesota, where harvesting supports local businesses. Yet, challenges like extreme weather and rising tech costs loom, pushing farmers to innovate to protect their harvests. As Emma tackles these obstacles, sudden storms can disrupt harvesting, delaying transport and causing stress that lowers pork quality. In Iowa's pork industry, harvesting moves thousands of pigs daily to processing plants, where robotic systems process 1,200 animals per hour, enough to feed millions. Farmers like Noah Bennett in Iowa feel the pressure as stressed pigs reduce meat quality, raising prices for families. USDA inspections use advanced imaging to detect contaminants in harvested pigs, ensuring safety for consumers like the Garcias in Texas. Harvesting also strains the environment as large-scale operations consume resources. Farmers address this with precision agriculture, using satellite-guided crop rotation after harvesting to restore soil health, sustaining production across states like Nebraska. The intensity of harvesting shines through in its technological marvels. In North Carolina, robotic arms equipped with machine vision monitor pig behavior, minimizing labor while prioritizing welfare. Timing is critical. Harvesting too early yields smaller cuts, while delays drive up costs. Labor shortages challenge farmers like Noah, who struggle to staff harvesting seasons. In Missouri, AI-powered barn systems predict growth patterns with 95% accuracy, optimizing harvesting schedules, though high setup costs remain a hurdle. These issues hit home as harvesting delays increase pork prices in stores, affecting families planning meals. Farmers bear this responsibility, knowing their work shapes the pork you enjoy. Despite these challenges, farmers deliver pork with remarkable efficiency. After harvesting, pigs are processed into cuts, sorted, and packaged, with blockchain-based traceability linking each product to its harvesting barn for safety. To tackle environmental impact, farmers in Illinois use biogas digesters, converting pig waste post-harvesting into renewable energy to power farms. Harvested pork becomes bacon for breakfasts or ribs for barbecues, connecting families like the Thompsons in Ohio to the land through every meal. Drones with thermal imaging and AI analytics now monitor barns, reducing harvesting inefficiencies by 25% in tech-forward farms, ensuring more pork reaches homes. This work sparks pride, fueling nutrition and traditions like 4th of July cookouts. Farmers push boundaries with next-generation tools to secure this legacy. In Kansas, smart harvesting machines with IoT sensors and machine learning track pig health in real time, boosting efficiency by 15%. Farmer Eva Chen in Illinois says we embrace technology to fight climate change and keep pork on your table using heat-tolerant pig breeds and gene-editing tools to adapt to shifting seasons. These innovations maintain steady supplies despite erratic weather. The film ends with a heartfelt call: support farmers by choosing locally harvested pork at grocery stores or farm markets. Harvesting weaves their dedication into the meals that unite families. This documentary celebrates the innovation and care behind every harvest, showing how America's pork industry feeds the nation while strengthening rural communities. From smart harvesting to sustainable practices, every step ensures pigs become the meals that warm American homes.
The U.S. leads in modern pig farming with major operations in Iowa, North Carolina, and Minnesota. A standard finishing barn in these states holds 1,000 to 2,500 pigs, following expert-recommended climate control, 65 to 75 DGF, automated feeding, and AI health tracking. Farrowing units ensure piglet survival, while group housing improves welfare. Farms use advanced manure systems to minimize waste, supporting eco-friendly practices. These innovations supply every processing factory with high-quality pork while boosting efficiency and sustainability. With over 700 pig farms nationwide, the U.S. continues to set the standard for large-scale, technology-driven livestock farming. Pork processing in the U.S. has transformed from manual, labor-intensive plants to highly automated processing factories, reducing costs and increasing efficiency. Today, advanced automation processes up to 250 pigs per minute, cutting labor costs by 30 to 50% while boosting output. Robotic butchers, $500,000 to $1 million per unit, and AI-driven quality control systems, $200,000 plus per plant, ensure precision and safety. With smart sensors and data monitoring, modern plants cut waste by 20%, setting a global benchmark for productivity and quality. Inside America's most advanced pork processing factories, intelligent automation is redefining efficiency, precision, and safety. With AI-driven vision systems, every cut is analyzed in real time, ensuring accuracy and reducing waste by up to 15%. Before AI, we relied on manual inspections, which weren't always consistent, explains a quality control specialist. Now, errors are detected instantly, improving overall product quality. Robotic arms handle processing with unmatched precision, ensuring consistency in every step. These machines don't get tired, says a technician. That means every portion is uniform, improving efficiency and meeting strict industry standards. Meanwhile, automated conveyor systems and IoT sensors monitor meat temperature, weight, and integrity. If equipment needs adjustments, the system predicts it before any issue occurs, notes a plant engineer. This proactive approach minimizes downtime and enhances food safety. With AI, robotics, and IoT working together, the future of pork processing is smarter, safer, and more efficient than ever. In modern pork processing factories, automation is not just about efficiency, it's about safety. With robotic systems now handling over 70% of repetitive, high-risk tasks, workplace injuries have dropped by 40% in the last decade. Before automation, tasks like heavy lifting and precision cutting led to frequent strain and accidents, explains a plant supervisor. Now robotic systems take on these jobs, keeping workers out of harm's way. For tasks that still require human involvement, exoskeletons reduce muscle strain by up to 60%, while wearable sensors detect fatigue and prevent injuries. These devices make lifting and handling much safer, says a safety engineer. With machines taking over physically demanding work, employees are shifting to technical roles. Training programs now certify over 1,000 workers annually in robotics and AI-driven systems. Instead of manual labor, they now manage automation, shares a training coordinator. This shift is creating a safer, more skilled workforce. By prioritizing safety and education, automation is not just transforming factories, it's transforming careers. Technology is making pork processing more sustainable and ethical, from waste reduction to improved animal welfare. AI-driven precision processing minimizes waste by 30%, repurposing byproducts into biofuels, fertilizers, and pet food. Energy-efficient machinery has cut water use by 40% per animal and reduced electricity costs by 20%. With many U.S. plants now using solar and biogas energy. Automation also improves animal welfare. Automated stunning systems keep pigs calm, reducing stress, explains a livestock expert. AI monitoring adjusts conditions in real time to ensure humane handling. With AI automation and renewable energy, pork processing is becoming more efficient, ethical, and environmentally responsible. In today's food industry, transparency is key to consumer trust. Advanced tracking technology is transforming how pork moves from farm to table, ensuring safety, quality, and accountability. Blockchain technology creates an unchangeable digital record of every stage in production, from farm conditions to processing factories and distribution. With blockchain, consumers can verify where their pork comes from in seconds, says a supply chain expert. RFID tracking and smart packaging enhance safety. Sensors monitor temperature during transport, preventing spoilage, explains a logistics manager. Smart labels provide real-time data on processing and storage, allowing shoppers to make informed choices. Hey Trending Farm subscribers! Global pork production is expected to reach 116.02 million metric tons in 2024, with China leading at 56.75 million metric tons, followed by the EU, 21.25 million, and the US, 12.68 million. Advanced processing factories use AI-driven monitoring and automation to ensure efficiency, hygiene, and humane treatment. Modern pig farming integrates automated climate control, precision feeding, and biosecurity measures to optimize health and meat quality. Pork remains a key protein source worldwide, supplying iron, zinc, and vitamin B12. This documentary explores the technology, regulations, and innovations shaping one of the world's most essential food industries. Modern pig farming integrates advanced housing systems to ensure optimal welfare and efficiency. The LED lighting system, costing approximately $100 to $300 per fixture, operates continuously to help piglets locate warm areas for nursing, reducing stress and mortality rates. Shutters with heat diffusers maintain an ideal temperature of 28 to 32 degc for piglets, preventing hypothermia and supporting early-stage growth. Specialized pig pens now feature sunbathing zones, which boost immunity and reduce disease susceptibility by 15 to 20%. Water systems are designed with separate sources outside the pen, preventing excessive moisture buildup and reducing infection risks by up to 30%. These improvements contribute to higher productivity and better meat quality in the processing factory, ensuring a sustainable supply chain for pork products. Cleanliness is key, says Mark, a sanitation supervisor at the processing factory. Each pig pen is designed with step platforms and separate doors to keep manure out of resting areas. This small detail makes a big difference in hygiene and disease control. Every day, farm workers follow strict hygiene protocols, scrubbing floors, managing waste, and disinfecting surfaces. We sanitize everything from barns to transport trucks because biosecurity is non-negotiable, explains Sarah, a biosecurity officer. Before transport, pigs receive a balanced diet to optimize meat quality. Drivers ensure safe handling, and upon arrival, veterinarians inspect each pig. Healthy pigs mean high-quality pork, Mark adds. It all starts with proper care from farm to factory. At a modern processing factory, pig processing is a highly automated and regulated operation that ensures efficiency, hygiene, and humane treatment. Pigs arrive in ventilated transport trucks and are guided into holding pens with anti-slip flooring to minimize stress. Stunning is performed using CO2 gas chambers or electric stunning systems, ensuring pigs are unconscious before further processing. Automated scalding tanks at 60 degc loosen hair, followed by mechanized dehairing machines and flame singeing for sterilization. Carcasses are chilled at 5 degc for 16 hours, then graded using autofoam scanners for precise quality assessment. Skilled butchers and robotic systems separate high-value cuts, ensuring optimal yield and quality for global distribution. Waste products are repurposed, with fat processed into biodiesel and intestines cleaned for sausage casings. Ever wondered how millions of sausages are produced daily with flawless precision? At a modern processing factory, the entire process is fully automated, ensuring hygiene, consistency, and food safety. A closed processing system certified by HACCP and ISO 22000 prevents contamination at every stage. High-quality pork is finely ground in industrial grinders, then blended in vacuum mixers with spices, salt, Using high-pressure stuffing machines, the mixture is encased in natural or collagen casings before entering steam or smoke chambers, where it is cooked at 75 to 85 DEC. Finally, automated conveyors transport sausages to vacuum sealing machines, ensuring freshness for global distribution. Egg farming is a cornerstone of global agriculture, featured in many farming documentaries, providing an important source of protein for billions of people. Each year, more than 1.2 trillion eggs are produced worldwide, with leading countries such as China, the United States, and India contributing significantly to this output. Modern farms typically use large, climate-controlled barns equipped with automated feeding and egg collection systems to optimize production. In contrast, smaller-scale operations and free-range farms provide outdoor areas where chickens can roam, meeting growing consumer demand for ethical and sustainable practices. China alone produces more than 35 million tons of eggs per year. And the industry continues to expand and evolve to meet growing global demand while balancing efficiency and animal welfare. Modern egg farms operate on an extraordinary scale, with some facilities producing over 5 million eggs weekly to meet rising global demand. In these large-scale operations, hens are housed in climate-controlled environments designed to optimize their productivity over a typical lifespan of 72 to 80 weeks. automated feeding systems deliver precise nutrition to thousands of birds simultaneously, while conveyor belts collect and transport over 700,000 eggs daily for sorting and packaging. A poultry farm manager explains in this farming documentary how such systems streamline logistics to handle enormous volumes efficiently. Meanwhile, an economist emphasizes the importance of egg farming in feeding over 8 billion people globally, underscoring its pivotal role in sustaining the world's food supply chain. Modern poultry farms use advanced technology to increase productivity and cut costs, the focus of this farming documentary. While programmable LED lighting systems improve egg-laying efficiency, costing between $20,000 and $50,000 per house. High-performance ventilation systems, costing between $30,000 and $100,000, maintain optimal conditions for the flock. AI health monitoring systems, costing $100,000 and up, detect early signs of disease, preventing costly outbreaks. Robotic egg sorting and packing systems, which process up to 120,000 eggs per hour, can cost more than $500,000. Experts agree that these investments improve efficiency, reduce labor by 30 to 50%, and bring significant profits for large-scale operations. In this farming documentary, we explore the life cycle of a hen from infancy to breeding age. After hatching, the chicks are raised in incubators, where they are kept warm and given starter feed until they are about 6 weeks old. At this stage, they are moved to designated barns or outdoor areas, depending on the farming method. At 18 to 20 weeks, the hens reach breeding age and begin laying eggs until they are replaced at 72 to 80 weeks. In confinement systems, they are confined in small spaces, with a focus on efficiency, while free-range systems provide more space for natural behaviors. Interviews with farmers show that while some choose confinement systems for efficiency, others prioritize animal welfare and the market demand for free-range eggs. Experts stress that any form of animal husbandry requires careful monitoring of the life cycle, ensuring maximum egg production while balancing welfare and activity needs. As highlighted in this farming documentary, egg farms face significant sustainability challenges, particularly in terms of water and feed consumption. Producing 1 kilogram of eggs requires 2,000 to 3,000 liters of water, with feed costs accounting for up to 70% for total farm costs. Waste management is another pressing issue, as poultry farms produce millions of tons of manure each year, contributing to ammonia emissions that can harm air and water quality. Recent studies, such as those published in the Journal of Environmental Management, have highlighted these environmental impacts. However, initiatives such as biogas plants, which use chicken manure to generate renewable energy, are helping to reduce carbon emissions by up to 20%. Additionally, experts such as Dr. Sarah Bennett from the University of California highlight the potential of insect protein as a sustainable alternative feed to address these challenges. Global consumer perceptions of eggs have changed in many farming documentaries, with growing demand for organic, pastured and free-range eggs due to concerns about animal welfare and health. In the United States, organic egg sales are set to soar 15% by 2023, while free-range eggs have seen steady growth of 7 to 10% annually in markets like Europe. Consumers are also prioritizing transparency, with 60% of egg buyers in a 2024 survey saying they consider ethical certifications when making purchasing decisions. Prices reflect these trends, with organic eggs typically costing 50 to 100% more than conventional eggs. Free-range eggs are also more expensive, averaging 25 to 30% more than standard eggs. We begin this farm documentary by exploring the sheep transport process. Sheep transport involves specialist vehicles designed for efficiency, safety, and animal welfare. These vehicles, powered by powerful 600 horsepower engines, can carry hundreds of sheep per trip in a cleverly designed 4-compartment system. The compartments ensure optimal space, comfort, and ventilation for the animals during transport. Advanced handling capabilities reduce sudden movements, minimizing stress on the animals. In addition, these vehicles often feature automated loading and unloading systems, streamlining operations and saving on labor. Combined with modern equipment, the transport process becomes a seamless blend of care, efficiency, and cutting-edge agricultural technology. In our farming documentary, we explore how these areas are designed to support efficient sheep farming. After transport, sheep are grazed in two main areas on farm and outdoor grazing, each designed to optimize health and productivity. On-farm grazing refers to pastures within farm boundaries, often managed with rotational grazing. For example, in regions like Australia, paddocks are typically 10 to 20 acres each, allowing for periodic rest and regrowth. In this farming documentary, we address the challenge of providing year-round feed for sheep, relying on efficient harvesting equipment. The Jaguar 25 single-row forage harvester 300 horsepower ensures fast, precise cutting. While the John Deere 8500 400 horsepower and 7980 up to 625 horsepower excel in high-capacity harvesting. Combined with the Valtra 6300 tractor 160 200 horsepower and Elho 240 rate 2.4 meters working width. This setup maximizes harvest yield, ensuring high-quality feed for sheep year-round. In this farming documentary, we showcase the Fendt 930 at Don Weiss Farm, where it uses a 2210 Grouser blade on 3 Fendt points for efficient silage preparation. With 710 double gears, a 12,000 lbs rear axle, and joystick controls for precise adjustments, this tractor excels in heavy-duty tasks. The New Holland T7.315 tractor 313 horsepower works seamlessly with the Big Bowler 1290 high-density square baler for efficient hay and straw baling. With a bale density of 120 kg M3, it maximizes productivity and reduces handling time. Priced around $200,000, this combination offers significant savings through enhanced efficiency, reduced labor costs, and improved storage and transport. After baling, farmers rely on transport equipment like the Anovi ARB2 self-loading bulk trailer, self-loading bale carrier Demi-Mix T18, and RBM 1400 Anderson self-loading bale carrier. The Anovi ARB2 has a capacity of 18 bales with a robust hydraulic system priced around $40,000. The Demi-Mix T18 can carry up to 18 bales and features a self-loading mechanism, costing approximately $35,000. The RBM 1400 is designed for larger operations, handling 14 bales and costing around $45,000. These machines drastically reduce labor time and improve productivity, enabling faster and more efficient transport compared to traditional manual methods. The Bal Express multi-bale feeder in this farming documentary efficiently handles round and square bales, reducing tractor movements and simplifying loading. Its adjustable design allows compact stacking, while a tilting elevator ensures precise feed placement and prevents contamination. With capacities of 6 to 10 bales and advanced features like the FeedLink app and onboard weighing, it boosts large-scale feeding efficiency. Siloking's Trailline Smart 5 mixer and Trioliet's Gigant 500 self-loading mixer both have a capacity of 5M3. With the Gigant 500 self-loading mixer eliminating the need for a truck. It has a capacity of 2M3, is designed for smaller scale use, and is mounted on a wheel loader or telescopic handler. Its compact design makes the Cyplo MB1500 ideal for use in tight spaces and stable. The Sirigstad one-touch feeder delivers precise feed distribution at up to 500 kg/hour, reducing waste by 20% and cutting labor by 30%. Built for durability, it handles silage and grains efficiently, making it ideal for farms of all sizes. Experts in the farming documentary praise its reliability and ease of use, boosting productivity and sheep health. The final part of this farming documentary, Trending Farm, looks at machines that help distribute mulch indoors and outdoors. The WSB140Z straw blower by VDMJ Machinery excels indoors, efficiently distributing straw in tight spaces. For outdoor tasks, the Cavernaland 86 provides precise handling, while the BalExpress multi-bale feeder optimizes feeding for round and square bales, ensuring efficient and uniform distribution. Together, these machines streamline operations both indoors and outdoors. What other equipment does sheep farming require? Keep watching this farming documentary to learn more. Hello friends. Transporting over 2 million sheep annually across regions like Australia and the Middle East demands cutting-edge machinery built for efficiency and care. Have you ever wondered how this enormous task is achieved with modern technology? Join Trending Farm as we uncover the secrets of farming in this documentary about the revolutionizing of livestock transportation. The Sirigstad one-touch feeder delivers precise feed distribution at up to 500 kg/hour, reducing waste by 20% and cutting labor by 30%. Built for durability, it handles silage and grains efficiently, making it ideal for farms of all sizes. Experts in the farming documentary praise its reliability and ease of use, boosting productivity and sheep health.
AI technologies are gradually developing and created by human hands. What if each processing factory gradually has fewer people working? Please share your thoughts below in the comments section of this video. And lastly, don't forget to recommend the channel to your friends so they can watch too. Thank you and goodbye. See you again in the next videos.